Students, in this class we will learn how to integrate integral 1 over ln x positive ln of ln x times dx. Now foremost, you have to know how to integrate ln x times dx. Now we would always use integration by parts, where we would use the concept of Lie, where L stands for logarithmic function, I stands for inverse functions, A stands for algebraic functions, T stands for trigonometric functions, and E stands for exponential functions. So clearly the U that we would take here would be ln x, and differentiating U, which is du, that's going to be 1 over x times dx. Now my dv is going to be whatever quantity that is left after you have assumed u, so that's going to be dx, and to get v we integrate both sides, so that is going to give us x. Now if we were to use integration by parts, then we know the formula u dv is equal to uv minus integral v du. This is the formula we would be using, where my u is ln x, my dv is dx, my u is ln x, my v is x, and my v is x here, my du is dx over x. So we can get it cancelled and we would get x times ln x negative dx. If we were to integrate this, we would get x times ln x negative x. So on the left it's integrating ln x dx. So if we were to have a quantity like this, ln x, then the usual way of using integration by parts leads us to this solution. Now the problem is simple because they have just given us ln x. Now what if they were to give you ln of x squared times dx? There would just be one challenge, that is, when we were to take u as ln of x squared, then when we are differentiating u, which is du on the left, we have to differentiate ln of x squared. So that's going to be 1 over x squared times differentiation of x squared. So that's going to be 1 over x squared times differentiating x squared would give us 2x. So this is what we have got. Now the idea is, if you were to say differentiate ln, or in other words, if you were given this question to integrate ln of ln x times dx, then how would you do the process, or how would you apply the tool of integration by parts? So in this case, what we would do, we would assign the entire quantity as u of ln x, and our dv is going to be dx. So differentiating u would give us du on the left, so differentiation of this quantity. Now imagine this quantity to be as x squared, so you are differentiating ln of x squared, so that's going to be 1 over the quantity within the parenthesis, that's x squared, so it's going to be 1 over ln x times differentiating ln x. So what would that be? That's going to be differential of ln x would give you x, 1 over x, right? And that has to be multiplied with ln x. So this is what you get for du. Now if you were to take dv, see, we know that dv is taken to be as dx, and to get v we are going to be integrating both sides, so that is going to give me v to be as x. If I were to apply the formula u times dv is equal to uv negative integral v du, then I would get something like this: integral ln of ln x times dx is equal to my u is ln of ln x, my v is x, so I can place that x there, negative integral, my v is x, my du is 1 over x times ln x, of course I need to place the dx there, times dx, right? So this is going to be cancelled, so I would now have integral ln of ln x times dx is equal to x times ln of ln x negative integral dx divided by ln x. So this is what I have got for integral ln of ln x times dx. So I would be using this fact or this information in solving the question. So what question we were given? We were asked to integrate 1 over ln x positive ln of ln x times dx. Now what I'm going to do, I'm going to rewrite this as integral. I'm going to bring the dx inside. So that's going to be dx of, or dx divided by ln x positive integral ln of ln x times dx. This is what I've got. Now clearly I have just shown you what is integral ln of ln x dx. I need to be substituting this quantity. So if I were to do that, this is going to be integral dx divided by ln x positive. In place of integral ln of ln x times dx, I would be substituting this. So that's going to be x times ln of ln x negative integral dx divided by ln x. Okay. Now this can be rewritten. So it's going to be integral dx divided by ln x positive x times ln of ln x negative integral dx divided by ln x. Positive integral dx ln x will be cancelled with negative integral dx ln x. So that's going to be giving me x times ln of ln x. Of course, this is an indefinite integral, so we are expected to add the arbitrary constants c. So therefore, just for the sake of consistency or continuation, I can simply write, therefore, integral of 1 over ln x positive ln of ln x times dx is obtained to be as x times ln of ln x plus arbitrary constant c. So that completes the solution to this question. Students, were given this question, integral 2 divided by ln x squared positive ln of ln x squared times dx. We are expected to integrate this. Now this is actually natural logarithms. Okay, this is to the base e, log to the base e. I would be calling it as ln, right? You are free to call it as ln or ln or natural log. It depends on you. So just for the sake of lucidity, I'm using the term ln. Now what I would do, I would rewrite this entire thing as integral 2 over ln x squared times dx positive integral ln of ln x squared times dx. Okay, this is the way I'm going to be rewriting the given quantity. Next, I would be consider integral ln of ln x squared times dx. I will be using the Liet rule, integrating by parts. So that would mean I would take u to be as ln of ln x squared. My du is going to be 1 over ln x squared times differentiation of ln x squared. That's going to be 1 over ln x squared times 1 over x squared times differentiation of x squared, which is going to be 1 over x squared times ln x squared times differentiation of x squared is going to be 2x times dx, which is rewritten as 2x times dx divided by x squared times ln x squared. X and x can be cancelled, giving me 2 times dx divided by x times ln of x squared. This is my du. Okay, my dv is going to be equal to dx. So when I integrate dv and dx, I would be getting v to be as x. Now the integration by parts formula is u dv is equal to uv negative integral v du. So my u is going to be ln of ln x squared, ln of ln x squared times my dv is going to be the dx there. So that's equal to my u is ln of ln x squared. My v is going to be x negative integral v is x. My du is this quantity there. So 2 times dx divided by x times ln of x squared. The x and x can be cancelled, giving me the following quantity: x times ln of ln x squared negative integral 2 times dx divided by ln x squared. So this is what I get for integral ln x squared times dx. So therefore the original question. So now what am I going to do? I'm going to be using this result for integral ln x squared dx. Okay, over here. This is the original question that's been given to us. So this is equal to integral 2 over ln x squared times dx positive. In place of this, I'm substituting this. So that's going to be x times ln x squared negative integral 2 over ln x squared times dx. Okay. Now clearly positive integral 2 over ln x squared times dx can be cancelled with negative integral 2 over ln x squared times dx. So that would give us x times ln of ln x squared. This is what we are getting. So therefore we can now conclude integral 2 over ln of x squared positive ln of ln x squared times dx is equal to x times ln of ln x squared positive arbitrary constant c. So this is the final answer to the given question.